Titration is a chemical technique used to determine the concentration of a solution by reacting it with a solution of known concentration. In a titration, a solution of a substance, the analyte, of unknown concentration is added slowly to a solution of a reagent, the titrant, of known concentration until the reaction between the two is complete. The endpoint of the titration is determined by the use of an indicator or a pH meter. An indicator is a substance that changes color when the reaction is complete, indicating that the analyte has been completely reacted with the titrant. A pH meter measures the pH of the solution, which changes as the reaction progresses. The amount of titrant required to react completely with the analyte can be used to calculate the concentration of the analyte. This calculation is based on the stoichiometry of the reaction and the known concentration of the titrant. Titration is commonly used in analytical chemistry to determine the concentration of acids, bases, and other substances in a variety of samples, including water, food, and pharmaceuticals. There are several types of titration, including 1. Acid-base titration. This is the most common type of titration, where an acid and a base are titrated against each other to determine the concentration of one or both of the solutions. 2. Redox titration. In redox titration, the titrant and the analyte undergo a redox reaction. The endpoint is determined by the change in oxidation states of the reactants. 3. Complexometric titration. This type of titration involves the use of a complexing agent to form a complex with the analyte. The endpoint is determined by the formation of a colored complex or by a change in conductivity. 4. Precipitation titration. In this type of titration, a precipitating agent is added to the analyte solution to form an insoluble product. The endpoint is determined by the appearance of a precipitate. 5. Coulometric titration. In this type of titration, the titrant is generated electrochemically by passing a current through the solution. The endpoint is determined by the amount of current required to complete the reaction. 6. Gas phase titration. This type of titration involves the measurement of gas phase concentrations by passing a gas mixture through a solution of known concentration. Each type of titration has its own unique set of requirements, and the choice of titration depends on the nature of the analyte and the purpose of the analysis.